Diagnostics in a device or diagnostic method is simply there to trace faults, or it can be used to trace our circuit. Which means if I have a pressure sensor and I doubt that whether it is generating signal or no, I can simply go to the parameter which can show the signal received, which will be either in milliamperes or voltage, or I can see as a pressure indication. This way I can check easily without the need to open the connection and check with digital multimeter. So this is diagnostics by monitoring parameters. Now how about if the VFD is damaged, or we do not know that whether the VFD is damaged or it is working fine? So that VFD will require hardware diagnosis. I will give just a small overview in this video. For complete diagnostics and troubleshooting, refer to troubleshooting manual which I attached in the resources, or contact a technician who is well suited for this job, since this job without any experience is dangerous. So please do not try deep at hardware level all by yourself. In monitoring, what we will be able to see, we can monitor digital inputs, we can monitor the relay, that which relay is active, or what are the analog signals we are receiving on the VFD terminals, and we can also know what is the analog output, and even we can check how much is the current motor is consuming, or what is the DC voltage level in the VFD. For hardware diagnosis, make sure that the VFD is in off condition for more than 10 to 15 minutes to be on safe side. And still, if you want to verify, then you can check the DC voltage at terminal P plus and N minus. In running condition for 400 volt VFD, the DC voltage can be around 530 volt DC. In off condition, the voltage could be as low as 20 volt DC. So I will begin with demo. In this demo, I will show you how you can make the hardware diagnostic for the VFD. So first of all, to the meter, you will make it a diode. Now it's in ohms, so I will select to diode, right? Now next thing, I need to check the diodes. So I'm connecting the red lead to line 1 and the black to the positive. So it should be open, it should be closed. So this is also closed, and this one is also closed, and the opposite should be open. So the value is going up and it will cross OL, it will show me OL. So that means it's open. With line 2 it's also open, and with line 3 it's also open. Now we need to do the same test with the negative terminal. So I'm giving the black one at minus and the red one at line 1. So it's open, line 2 is open, and line 3 is open. And we need to do the opposite, and it should give us opposite result. So diode is closed here, it's closed here also, and it's closed here also. So this means the diode is okay, as you can see on the table. Now for the IGBT, again the same procedure. I'm keeping the positive, the red lead on positive, and the black on U. So this is open, V is also open, and W is also open. And when I will make it opposite, and it's showing me close, it's also showing me close, and here also it's closed. When I should connect with negative, it should give me open, open, and open, and the opposite should be closed. So now I put the red lead on negative and the black on U, it's close, V is close, and W is close. So that means the hardware is okay, the diode and the IGBTs are okay. If I want to check that whether I'm getting the digital input or no, so instead of tracing the wires and using the multimeter to check the connectivity, I can simply go to IN group, and here I can see the status if I can get a signal or no. So this will reduce our time spent on checking the wiring, the drawings and all these things, and just we can see here what is the status, if there is any input which is active or it's deactivated. And similar to this we have for the output also. Here I can check the output status. If for example there is relay which is working, so we'll see here that which relay is active right now, and we can diagnose that if the relay is working as it's supposed to be and where we need to debug the system. Now consider another scenario that if I have the sensor which is 0 to 10 volt and it is connected to the VFD, but I need to see if I'm getting any reading or no. So if I have connected the sensor which is 0 to 10 at V1 terminal, so I can go to IN number 5 and I can see the value. So here I have a device which can simulate as a sensor. So I will change the value and you can see the result. Now I change the value and here I'm getting the result 3.15 volt. Other diagnostic, like for example DC link voltage, I can select, and now I'll be able to see what is the DC link voltage for this PFD without connecting my multimeter. And here I can see the amperes, the voltage, and what is the frequency if it's running. This STP means that it's stopped right now, and once I press it again and you'll see it's FWD, which means forward. So this will help us in diagnosis.